Hello everyone, welcome to Equal To, and in this video we are going to see the in-text questions of this chapter, Is Matter Around Us Pure? And this is the 7th video of this chapter, and if you haven't seen the past 6 videos yet, I'll give you a link, you can go and check it out, and we'll move on to the questions now. So the first question is, what is meant by a substance? So what is a substance? A substance is something that contains single type of particles. So in the sense you can tell it is chemically pure. It has only single type of particles and they have definite properties and composition. So unlike a mixture, they have definite properties and composition. So that is what a substance is. It has single type of particles and it has definite properties and composition. Now moving on to the next question. The next question is, differentiate between heterogeneous and homogeneous mixture. So there is multiple points to this question. We'll look at it one by one. So the first difference between homogeneous and heterogeneous mixtures is that homogeneous mixtures are uniformly distributed. The solute particles are uniformly distributed in the solvent. So that is in case of a solution, but generally speaking, it's uniformly distributed throughout the mixture. Whereas in heterogeneous, although it is completely mixed, you can distinguish with your eyes or under a microscope the particles. Like you will be able to clearly distinguish between the particles either with your eyes or with a microscope. Now please bear with me, after a few points we will have an example as well, so you will get to know every single thing about homogeneous and heterogeneous mixture easily and the differences between them if you stick around. So we have also already seen these things if you have watched the other videos. So this is just a recap, you might say, and also this will be asked in your exams. This might be asked in your exams. So that is that. Now moving on to the second point. The second difference between homogeneous and heterogeneous mixture is that in homogeneous mixture there is uniform composition. So that is what what exactly it means is that it's very similar to the first point, which is it's uniformly distributed, but also if you take 1 ml of that mixture or 100 ml of that mixture, no matter how many amount you take of it, the distribution is uniform. So that is what they are trying to tell. Okay, so uniform composition in the sense, let us assume we have 10 ml of salt water, and if we take 100 ml of that same salt water, the composition of the salt and water will remain the same no matter how much volume you take of it. But in case of heterogeneous mixtures, that may not be true. So a heterogeneous mixture might be salt and pepper mixed together. Now if you take a pinch of it, you cannot exactly say how much particles of salt or how much particles of pepper you have, and if you take a different pinch, you'll have different composition, you'll have different amount of salt and pepper in it. So that is what they mean by uniform and irregular composition. Okay, now moving on to the third point. The third difference between heterogeneous and homogeneous mixture is that you have no apparent boundaries of division in a homogeneous mixture. So in a salt water, you will not be able to you will not be able to draw a boundary or divide between the salt and the water particles, right? So that is what they mean by no apparent boundaries of division. Whereas in a heterogeneous mixture, you will be able to clearly define or draw a boundary between the different particles that is mixed in the heterogeneous mixture. So that is another difference. Now the last point when it comes to homogeneous and heterogeneous mixture is that examples of homogeneous mixtures are salt, water and sugar solution. For heterogeneous, you can think of anything like I told, salt and pepper mixture is a heterogeneous mixture. Chicken noodle soup might sound confusing to you, but what it has is, it has chicken pieces, it has noodles, it has some flavored water in it. So all this combined together is chicken noodle soup, and they're not exactly uniformly mixed. It's a heterogeneous mixture for sure, obviously. And the second example could be chocolate chip cookies. So it has the dough, it has the chocolates, and although it's a mixture, it's not homogeneous. You can clearly draw boundaries between the choco chips and the cookies. So that is all the differences between homogeneous and heterogeneous mixture. A quick recap. So in a homogeneous mixture and heterogeneous mixture, the distribution is uniform and homogeneous, whereas you can draw clearly, you can distinguish between the particles in heterogeneous. and the composition is uniform and homogeneous, whereas in heterogeneous it has irregular composition. There is no apparent boundaries of division in homogeneous, whereas there is noticeable boundaries of division in heterogeneous. An example for homogeneous is salt water and sugar solution. For heterogeneous, chicken noodle soup and chocolate chip cookies, and also you can consider anything that you can imagine, salt and iron fillings, anything, salt and pepper, or these are heterogeneous examples. Now, moving on to the next question, you are supposed to distinguish between or write the differences between a sol, a solution, and a suspension. So a sol is a type of colloid. If you don't know what a colloid is, please watch the previous video. We have discussed what a colloid is in detail, and we also discussed some examples of sol along with what a sol is. Now in this video, in this particular section, we are just going to look at the differences between sol, solution, and suspension. All these things we have already seen. So if you haven't, please go and watch them first so you understand these things well. Okay, so a sol is a heterogeneous mixture. A solution is a homogeneous mixture, obviously we know that, and a suspension is also a heterogeneous mixture. So when it comes to the category type of mixture, sol is heterogeneous, solution is homogeneous, and suspension is again heterogeneous. Now the second point is that size of particles. So how are the size of particles are different between sol, solution, and suspension? In a sol, the size of particles range from 10 power minus 7 to 10 power minus 5 centimeters, whereas in a solution, they are less than 1 millimeter, which means that they will not be able to scatter light even. But in a suspension, it's more than 100 nanometers and it will obviously be able to scatter light, and you will be able to trace the path provided the solution is stable currently when you are trying to do this test. Now these are things we have already seen. Okay, so the size of the particles are 10 power minus 7 to 10 power minus 5 in sol, less than 1 nanometer in solution, and more than 100 nanometers in a suspension. Now the next difference is that Tyndall effect. When it comes to the Tyndall effect, sol exhibit Tyndall effect, whereas solutions don't exhibit Tyndall effect. You will not be able to trace the light, and in suspensions they may or may not exhibit Tyndall effect based on the suspension. So that is something that cannot be determined generically. Okay, so sols exhibit Tyndall effect, solutions do not exhibit Tyndall effect, suspensions may or may not exhibit Tyndall effect. The next property that we are going to compare is that appearance of sol, solution, and suspension. So sol appear glassy and clear usually, whereas solutions are very clear, they are unclouded, whereas suspensions are either cloudy or completely opaque in nature. Okay, the next category is visibility. Visibility in the sense the particles, how you can see them. The particles are visible in a sol only under an ultra microscope, whereas in a solution it's not visible at all. But in a suspension, you can even see the particles, you can easily draw the boundaries just with your naked eye. You don't even need any instrument to do that. That is the visibility level in suspension. Now the next thing is diffusion. Sol diffuses very slowly, whereas solution diffuses rapidly, and suspension do not diffuse at all. And the next thing is stability. Sols are pretty stable, solutions are highly stable, meaning no matter how many hours you leave a solution untouched, they will not become unstable. They'll remain the same way when you left it hours ago. But in a suspension, it's clearly unstable. We have seen already, when a suspension is kept untouched, it settles down. So the suspension is unstable. Okay, now sol gets settled only when centrifugation is done. Centrifugation is something that we haven't seen yet, we'll be seeing soon, so please consider subscribing. So getting settled, sol gets settled only in centrifugation, solution do not settle at all, and suspension settles on their own without even doing anything. Okay, now coming to the last point, we are just going to give examples of these. Milk, blood, and smoke are examples of sol. Again, we have also seen some examples in the previous video, so you can also refer that. Now for solution, salt solution and sugar solution are examples of a solution. Sand and water and dusty air are examples of suspension. You can think of multiple examples for suspension on your own, it's quite easy. Now that is all the difference between salt, solution, and suspensions. Just remember the categories and you will be able to fill in those things, right? Now moving on to the next question, In this question, you are going to solve a mass by mass concentration problem. So we already have a video on mass by mass concentration problem. So we pretty much know how to solve this problem. We are just going to go through this and try to solve it. Okay. Now, if you don't really know, please go and watch that video first. Everything will be in the playlist. And if you know, we can move on. Now in this question, to make a saturated solution, 36 grams of sodium chloride is dissolved in 100 grams of water at 293 Kelvin. Find its concentration at this temperature. So this is the question. Now reading this question, you can tell that 36 grams of sodium chloride means the solute is sodium chloride and the mass of solute is 36 grams. And the next part is it has been dissolved in 100 grams of water, meaning that water is the solvent here and the mass of water is 100 grams. Now we know that the formula is for mass by mass concentration is mass of solute divided by mass of solution into 100. Now we have to calculate mass of solution in order to proceed. Now mass of solution is just mass of solute plus mass of solvent, which is 36 plus 100 grams. That adds up to 136 grams. So the mass of solution is 136 grams in this case. Now we are just going to plug these values into the formula, which is 36 grams mass of solute divided by 136 grams mass of solution into 100. That gives us 26.47 percentage. So the concentration, so the mass by mass concentration of this particular solution is 26.47 percentage. That is it for this question. I hope you understood this. Now, if you're not clear with this, we have dealt this in detail in that video, which has a question clearly explained on how to solve this. I just rushed through it. It's quite easy. If you haven't watched it, please go and watch it. Now, that is all for this video. We have solved 2 NTEX question sessions and stay tuned for the next video. Thank you so much for watching this one. If you have any doubts, please put them in the comments. I'll get back to you as soon as possible. And if you liked it, please like the video and consider subscribing to Equal To. Thank you so much. See you in the next one. Bye for now.